I bought this SB-200 on eBay, and I'd like to get it to work with my Icom 745. So I have to do some mods. Looking at the schematic here, I noticed it was already recapped when I bought it, so I don't have to deal with the capacitor network here and the main filtering. I'm having some problems with it oscillating in the 10 megahertz band, so I'm going to have to find a way to neutralize these 572s. I have brand new 572 Taylors I purchased for it. Also, I'm going to do a little work down here, design a little circuit to add the ability to key this thing from a solid state radio. And I want to look at this input network, see if I can't make it match 50 ohms. Because in the old days, when you had an SB-101 Heathkit connected to this thing, the plate and load adjustments were able to adjust the SWR discrepancies out of the coupling between the transmitter and the amplifier. I don't have that coming from a solid state rig unless you were to put a tuner in between, which would be kind of a pain because a lot of cases you got a tuner on the output also. So you got two tuners to deal with every time you change band. So I'd like to somehow make this tuned circuit situation here a little bit more friendly to a 50 ohm load. So that's another part of the project we're going to try there. And like I said, the neutralization issue and maybe just a few other little things here. I'm going to draw up a schematic with the modifications I plan to make and see how that comes out. Before I tried anything else with the amplifier, I thought I would change out these parasitic filters here, going to the plate caps. I've been told to try a hairpin idea there that might work a little bit better. I'm going to try that to get rid of the 10 meter oscillation first, then go from there. So here I've got the hairpin loops, Teflon coated wire. It did not affect the oscillations at all on 10 meters. So the amplifier still goes to full output in oscillation mode on the 10 meter band. But I'll probably just leave these. I'm going to try a different approach here for neutralizing this. I found this method of neutralizing the amplifier from W8JI. And this makes a lot of sense, and I'm going to give it a try, where you give it just a little bit of feedback. You grab some signal from the plate side of the tube, and you feed it through a toroid, and use the toroid as your inversion. So the signal will be 180 degrees out of phase, and you feed it back to the cathode. And it won't take very much signal to stop that oscillation on the 10 meter selection of the amplifier. So this is a pretty good article on this, and I'm going to build one up and see how it works out. I'm not sure if I have these core materials. I have a box of cores. I'll take a look and see what I have. But this is kind of the idea. You come in one phase. If you notice, the start of the transformer on the plate side is connected, and the finish of the transformer opposite winding goes to the cathode. So you've got your 180 degree phase shift here. So I'm going to give that a shot and see how that works. He even mentions in the text here that 15 and 10 meters is usually where these amplifiers start to oscillate. They start to become unstable. And that's where the neutralization really becomes an issue. So I'm going to try this method and see if that will take care of the oscillation problem. I have a box of miscellaneous cores. I think I'm going to go with this real small one here. I'm not sure what the core material is on this, but I'll give it a try anyway. Yeah, it's pretty small. I'm sure this color code means something, but I'm not really sure what. So I'm going to wind a bifilar winding on here. 2 windings, exact same turns in bifilar mode. Install it in the amplifier and see if it's going to work out. I've got the transformer wound on that little bitty donut core. I used number 28 wire, 30 turns, bifilar wound. I got a solder lug mount that is exactly between the two 572s. This is the pickup pigtail here This is what will pick up the RF on the plate side of the tubes. It's just a pigtail, and it comes down to a porcelain spacer here. I will probably change this to Teflon later, but for experimenting this will do fine. On the other side of the panel here, this is where the capacitor comes through the bottom plate here of the tubes. It's 1,000 picofarad, and it couples the transformer to the filaments of both tubes. A lot of bad soldering here, or when I got the amplifier. I'll have to try to clean that up later. For now, we're going to use this just to test the amplifier and find out if it's going to oscillate or not. Here's another shot of the transformer that's mounted on the solder bracket there. Here's with the tubes mounted. Hopefully that pigtail will pick up enough RF from the tubes to feed back negatively to the cathodes. With a preliminary test, it looks like the phase inversion coil setup here seemed to work pretty well. There's no more oscillation on 10 meters or 15. I replaced the bare copper wire with this high temperature Teflon wire. So we're all set here, I think, with the neutralization issue. I had to come up with a design to key the SB-200 from a solid state radio with a low voltage control output. I designed up this circuit here. It's kind of simple. It takes a DC plus or minus. The bridge makes it to where the polarity really doesn't matter. A key-in voltage of 5 to 30 volts. That'll come from the Icom 745, which I believe puts out about 8 volts on its auxiliary connector. Then it comes into the bridge here. This is a Zener diode that kind of clamps any more voltage than allowed to go across this LED inside of the solid-state relay here. This is a high-voltage solid-state relay. I think it's 300 volts on its relay side. So it takes the 130 volts that normally would key the SB-200 that would be sitting on the key input. So we needed to buffer that away from the solid-state radio keying circuit. So this opto relay does the job for that. So we take the 130 volts and apply it to this PNP transistor when the radio out here is keyed, and it turns on this LED and this conducts. Then the Q1 gets turned on and it keys the amplifier. This goes to the key relay, which originally went to the phono jack on the back to be keyed from an earlier type of radio like an SB-101. So the high voltage there wasn't an issue, but it certainly is now. So this little circuit's for that. I added a meter calibration circuit onto the board, and this hooks to the bottom of the high voltage meter resistor ladder, so I can calibrate the meter to read the exact plate voltage. So I'm going to design up a PCB for this little circuit here, etch it, and place it into the SB-200. This is just a quick view of the printed circuit board layout. Shows all the components here. And I'm going to make a negative and etch a board for this little circuit and place it into the amplifier. Okay, I have the PCB etched and built, and it is mounted now on the bottom of the SB-200. So we're ready to start some of the other mods to the amplifier. I wanted to start working on the SWR issue on the input of the amplifier when connected to a solid state radio, which has a fixed 50 ohm output impedance. Now the specifications of the amplifier here say that the input impedance is 52 ohm unbalanced broadband pre-tuned input circuit, requires no tuning. But the measurements I took, this is really nowhere near 52 ohms, or the SWR between the radio and the amplifier would have been a lot better than what shows up. I'm getting on average about 1.6 to 1, 1.7 to 1 on all bands. I'm going to start looking into the coils themselves and try to find a way to tune out this SWR issue between the radio and the SB-200. These are the tuned circuits I'm going to try to adjust to create a 50 ohm input so I can directly connect the IC745 to the SB-200 without any tuner in between and try to get the best SWR I can in the center of each band here. So I'm going to work on 80 through 10. It's going to take some experimenting to get these coils and the capacitors that go with them tuned correctly. So I may have to even add turns or pull turns off to get things going. So I spent about the last 4 hours coming up with a combination of capacitance and inductance here on each band. These cores are out a little bit farther than I would like, but I would have to adjust turns here to get them in the core farther. So I would have to remove a turn here because as the core goes in, the inductance goes up. So I would have to reduce inductance by taking a turn off here. I really don't want to do that. Same with this. So right now they're not too bad. 15 and 10 are still kind of an issue. Another problem with 10, especially 10, is that all this unshielded wiring here. The 10 is all over the place, and depending on how long this wire is and the wafer switch where it's at, because you've got these stray wires unshielded going all over the place, this 10 meters especially just becomes really hard to keep adjusted. It's just too much unshielded for 28, 29 megahertz to be stable here. It looks like the 80, 40, and 20 is in pretty good shape. The 15, the 10 has still got some issues. This is a comparison of the input circuitry to the SB-200. The right here is the original values, and these are the changes I made on the left to bring in the SWR. This area right here, this is on the cathode side of the tube, and this side of these circuits are from the source or the input to the amplifier. The 80 meter originally was just a 470 picofarad on the cathode side and nothing on the input side. To tune in the SWR, I had to parallel a 500 picofarad and a 270 picofarad on the cathode side, and on the input side a 270, and that brought the SWR pretty close to 1-to-1. 40 meters, originally a 310 on the cathode side and a 510 picofarad on the input side, and I changed it to a 300 picofarad cathode side, 360 picofarad on the input side, and that brought that one in to close to 1-to-1 SWR. And then the 20 meter started with a 200 picofarad on the cathode side and a 360 picofarad on the input side, and this ended up being a 13 turns on the 20 meter coil, 120 picofarad cathode side, a 200 in parallel with a 47, so a 247 picofarad on the input side. These I still have to work on. Originally, just the cathode side had 75 puff for 15 meter and 68 puff for 10 meter. The 15 here isn't too bad, but I have no capacitance on the cathode side and 100 puff on the input side and 10 turns for L2 here. 6 turns for the 10 meter, and right now there's no capacitance there. And a lot of this is the problem of the stray capacitance and inductance that's in these unshielded leads that come in and out of the wafer switch, and it's making 10 meters quite difficult. But these are the values that I have right now. Going to run some tests here. Connect this dummy load, good for 250 watts, up to the output of the SB-200. I'm going to run some input SWR tests. I'm going to calibrate the SWR here. This is a measurement all the way through the amp into the dummy load, and we show that here, low relative power. This is with the amp turned on, and this is the SWR into the amplifier itself. There's no amplifier bypassed, and there's amplifier again. So the 80 meter coupling looks really good. This is 40 meters. Going to try the coupling there. First we'll set the forward for the SWR. Then this is to the load, and then it just switched to the amplifier. So we got about a 1.1 to 1 SWR. Now for the 20 meter test, going to forward the SWR. We'll check into the dummy load right there. Is almost 1 to 1. Now we flip on the amplifier and it's about 1.15 to 1 being coupled into the amplifier. So 20 meters is looking real good too. Now I'm going to test 15 meters. So we got the SWR forward set. Into the dummy load, it is 1 to 1 pretty much. And here's one of the problems, 1.5 to 1 into the amplifier. That needs to be worked on a bit. So that'll be for a future project. Now for the 10 meter test, we'll do it 29 megahertz. Forward the meter, set, and look at the SWR into the dummy load directly. And it's about 1.1 to 1. Now, here's the problem, 1.6 to 1 into the amplifier on 10 meters. Not a good thing. So that's to be worked on also. Back to the page of modifications. There's a couple other items I have added here. One was a slow start for the filaments of the tubes. And I used a very high current thermistor here. And the thermistor is in series with the filament winding of the transformer. I was originally going to put a slow start at the input. That's a board I'm going to have to design at a later date. My main issue was having the filaments here slow start, and this works really well. In fact, I have a spec sheet on that. This is the spec sheet on the SL22 1R020. This is a thermistor that you use for slow start. It's a 20 amp device. It has a resistance of 1 ohm starting out. Max current, it goes to about 0.03 ohms at 50% current. So there's very little drop across this in the filament winding of the transformer with the two 572 filaments on it. And the only other thing on that winding is the lamp for the meter. So this is the slow start for the tube filaments, and it works pretty well. Here's how that thermistor powers up the filament winding. You see it's very, very slow power up. So that's pretty much the mods that I've made. There's a couple additions here. I put back-to-back diodes across the meter to protect the movement. The meter movement is very sensitive, so the 0.7 to 1 volt drop across these diodes is not going to affect the meter at all. And that'll protect it just in case something happens, because getting one of these meters nowadays could be pretty tough. And of course, this is the high voltage meter calibration. This was the circuit explained earlier to key the amplifier. So what used to go to the antenna relay input now is driven by this transistor. I changed the SWR bridge diodes to Schottky. Here's the phase inverting transformer to neutralize the tubes. That's working really well. The hairpin parasitic filters. I made a change here to 1000 puff. I'm not sure if that is going to stay put or not. There's some experimenting I was doing here. So right now this is 1000 picofarad. And of course I got the 10 meter and the 15 meters to work on here. I still need a tuner in between the HF rig and the amplifier if I'm going to use 15 or 10. So that's about it for the mods on this thing. Oh, then these are 1000 puff silver micas now, C14 and 15. And of course a high voltage fuse. So that's pretty much all of the mods that I've made on this thing. And it's working really, really well. So I'll be using it quite a bit here.